All right, let's go over all of the questions for the review. First question says simplify. We are simplifying this expression by taking the parts that have the same base and subtracting their exponents. This will equal x to the 10 minus negative 8 is going to be 10 plus 8, which is 18. So that turns into x to the 18th power. And then for the y's, we are going to subtract 6 minus 11. 6 minus 11 is negative 5, so we have y to the negative 5th power. We know that you should never have a negative exponent in your simplified final answer. The x to the 18th stays in the numerator, but the y to the negative 5th goes into the denominator and turns into y to the 5th power. For number 2, we are also simplifying exponents, but in number 2, all of the parts are just being multiplied. So we're going to take common or like bases, and we are going to add their exponents. For the x's, negative 5 plus 9 is 4, so this turns into x to the 4th power. For the z's, we have z to the 2nd power plus z to the negative 2nd power. Well, they're being multiplied, but we take the exponents and add them. 2 plus negative 2 is 0. And then for the y's, y to the 12th and y to the negative 8th. 12 plus negative 8 is 4. So we have y to the 4th power. We know that anything to the 0 power equals 1. So essentially, we don't have to write that at all. So our final answer is just x to the 4th, y to the 4th, since z to the 0 power just equals 1. For number 3, we are taking the stuff inside the parentheses and basically distributing this new exponent of the 3. Everything gets this new exponent. If it has an exponent there already, you multiply it by 3. 2 technically has an invisible exponent of 1. So this will turn into 2 to the 3rd power since 1 times 3 is 3. X to the negative 12th power, y to the 15th power, z to the 6th power. We then simplify what we can. Negative exponents are not considered to be simplified, so that part needs to move and it'll move to the denominator. Everything else will stay in the numerator. 2 to the 3rd power really equals 8. We have y to the 15th, z to the 6th, and then the x to the 12th power is the only thing that gets moved to the denominator. Number 4, we have a couple of things that we have to do. First thing that I see is there's parentheses on both parts of the problem, but the parentheses to the right have this 2 here. I have to distribute this 2 to everything just inside of these parentheses first before I can ever multiply it by this one. So what happens here? Everything gets this new exponent of 2. So the problem really turns into 3s to the 4th t to the negative 3rd times 5 squared s to the 8th t to the negative 4th. These parentheses now are just showing multiplication between 2 separate things, but they're really not needed. What we're going to do is multiply the regular coefficient numbers and then combine the exponents through addition. So let's look at the regular coefficient numbers. 3 times 5 squared. You can do this in your calculator. 5 squared is 25, 3 times 25 is 75. And then looking at common bases, s to the 4th, s to the 8th, that's s to the 12th, t to the negative 3rd, and t to the negative 4th. You add that, that's t to the negative 7th. Any negative exponent is not simplified. So what happens is the 75 and the s to the 12th stays in the top, but the t to the negative 7th drops down to the denominator and turns into t to the positive 7th. For number 5, we are taking polynomials and we are adding them. For number 6, we're taking polynomials and subtracting them. When we're adding or subtracting polynomials, you combine like terms through either addition or subtraction. So looking at number 5, we have negative 2x to the 2nd power plus 5x to the 2nd power. I know that this is an addition problem because of that plus sign here. I know that the next one is a subtraction problem because of the minus sign. These two things are not being multiplied, they're being added. Negative 2x squared plus 5x squared is 3x squared. Moving down the line, negative 3x plus 15x is going to be a positive 12x. And then the plain coefficient numbers, we have 13 plus that minus 8 there, which will turn into a positive 5. None of these things are like terms, so that would be your final answer. For subtraction, like number 6, you have 2 options. You can either distribute the negative to everything behind it and then combine like terms, or you can actually go through subtraction like I did with number 5, but instead of addition, subtraction. I kind of prefer the distributing the negative. So I'm going to rewrite the first polynomial without the parentheses because the parentheses then won't be needed for that one. But everything behind this minus sign is going to turn into the opposite of what it is because we're distributing a -1 to the 5x to the third, which turns into -5x to the third. -1 times -2x squared, positive 2x squared, and then -7x plus 2. We then combine like terms. 3x to the third minus 5x to the third, that's -2x to the third. Putting it in standard form, we would look for x squared next. And actually, I forgot this was a positive 2x squared, not just a plain 2x. So there's only one of them. So it's going to be right here, just plus 2x squared. Looking at the x's, we have 7x, and then this is a minus 7x. They end up canceling out. And then the constant numbers, we have 9 plus 2, that's 11. So this would be your final answer since nothing else can be combined together. On to the next page. Multiply and simplify are the directions. This is 2 terms times 2 terms. We have the acronym FOIL to remember how to multiply 2 terms by 2 terms. 4x times x is 4x squared. 4x times 5 is 20x. -1 times x is -1x. -1 times 5 is a -5. Be careful in the final because it's very possible that this answer is one of the 4 choices, but this is not simplified. We can combine these like terms here and subtract 20x minus x and get a 19x, and that would be your final answer. Number 8, the directions are the same, multiply and simplify. You have to understand that this rule for the exponent rules, the power rule, does not work for this problem because of this plus sign. You cannot distribute that power of 2 to everything inside and say your answer is x squared plus 9. It doesn't work that way. You have to first expand the problem and make it x plus 3 times itself. Then you have to FOIL. X times x is x squared. X times 3 is 3x. 3 times x is another 3x. 3 times 3 is 9. Combine like terms. 3x plus 3x is 6x. So this would be your final answer. Number 9, the directions are again the same. We are still multiplying and simplifying, but we're now multiplying a 2-term polynomial times a 3-term polynomial. There's no acronym to remember how to do this. So you just kind of have to understand that when you're multiplying one polynomial by the other, you multiply each thing by everything in the other one. So I multiply x times x squared, x times 2x, and x times 4 first. X times x squared is x to the third. X times 2x is 2x squared. X times 4 is 4x. Then I multiply 3 times x squared, 3 times 2x, and 3 times 4. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times 4 is 12. So we have all 6 of these terms. We combine like terms. X to the third power doesn't have anything to combine with it. 2x squared plus 3x squared is 5x squared. 4x plus 6x is 10x. And then that constant of the 12 doesn't have anything to add with it. All right. The opposite of multiplying out and simplifying is factoring. So for number 10, they tell us factor completely using the greatest common factor. That means the biggest thing that goes into all terms for this polynomial. The biggest thing that goes into 18y squared plus 54xy squared is not going to be just like 9. Yes, you can take a 9 out of both of those terms and you can have a factored answer, but factoring completely means take the biggest thing out. The biggest number that goes into 18 and 54 is 18. And the biggest number of the biggest variable you can take out of both would be y squared. So you pull out a y squared from both. And because you're taking 18y squared from the entire first term, you have to have 1 here as a placeholder. And then 54 divided by 18 is 3. And 54xy squared divided by y squared, you'll just have to have an x here. So this would be your answer in factored form using the greatest common factor. Don't forget, you can always check your work by taking your answer, multiplying it back out to verify that it equals the original problem. Factoring by grouping, you need 4 terms to factor by grouping. You draw a line after the second to split it up into basically 2 different sides. You then factor by the GCF for each side. The greatest common factor of x to the 4th and 3x to the 3rd is x to the 3rd. So you take each thing, you divide it by x to the 3rd, and in this case, you're left with x plus 3. Then for this one, if this is ever negative, this 3rd term here, you have to take a negative out when you factor. The greatest common factor would be -2. And when I do that, I'm left with an x plus 3. Every time you factor by grouping, what's left inside the parentheses will match. And that allows you to regroup your answer as x to the 3rd minus 2 all times x plus 3. And then number 12, factor completely. Sometimes factoring requires you to do more than one step. So every time you complete a problem, you should always ask yourself, can I do more? The first thing you can do is pull out a greatest common factor of 2 from both of these terms, and you're left with x squared minus 64. This answer here will be one of the 4 choices probably on the final. It's really important to look inside the parentheses and ask yourself, can I do more? X squared minus 64 is a difference of squares problem because x squared is a perfect square, 64 is a perfect square. You can factor this further into x plus 8 times x minus 8. If you were to FOIL that back out, this equals x squared minus 64 because you basically take the square root of x and you put an x here, or sorry, square root of x squared, and you put an x here and here, and the square root of 64, 8 and 8. One's positive, one's negative. So your final answer would be 2 times x plus 8 times x minus 8 for number 12. For number 13, again, you're factoring completely. Look first for a GCF. We don't really usually deal with anything more than to the 2nd power when factoring. So I've noticed that they share a common factor of x. Let's take an x out first, and we're left with this, which then can be, again, factored further because this is another difference of squares problem. So that would be your final answer. For number 14, this is the first question that we're seeing, a trinomial that we have to look for what multiplies to be this and adds to be this. So remember, when you have a polynomial in standard form, ax squared plus bx plus c, and this number here is not 1, you have to figure out what multiplies to be a times c and also adds to be b. So we multiply 3 times -12, that's -36, and then the b number is -16. So we have to find the factors of -36 that add to be 16. So when you do that, you would just list all of the factors of 36 and then find the special pair that do exactly what you need. It's going to be -18 and +2 because -18 times 2 is -36, -18 plus 2 is -16. You take the original problem, 3x squared minus 16x minus 12, and you take that minus 16x and you split it up into the 2 things you just found over here. It turns it into 3x squared in any order minus 18x plus 2x minus 12 so that you can factor by grouping. You take out the greatest common factor of both. You'll be left with the same stuff inside the parentheses. You then regroup. 3x plus 2 times x minus 6 would be your final answer. Don't forget, you can always take your final answer and multiply it out to make sure that it works. Okay, the next one is again another factor completely question. So for this one, I noticed that the variables have like the largest exponent is a 3, and we don't deal with that usually right here. And I noticed the numbers are kind of large. That's because you can take a greatest common factor out. Before you do anything, you should take a 3 out and an x out of each term to reduce the problem that you have to factor further. You will then be left with 2x squared plus 9x minus 5. Now, this is easier to deal with. When I go to try and factor this further, I multiply the a and the c number and get -10, and it has to add to be the b number, which is 9. We find the factors of -10 that add to be 9. Well, it's going to be a +10 and a -1. So what I do here is kind of like factor 2x squared plus 9x minus 5 on the side. I split the 9x into 10x minus x. I get 4 terms, I factor by grouping. Make sure you take a -1 out of here. These all match up, so I can regroup it as 2x minus 1 times x plus 5. Don't forget that just this part here, this answer here, this is not the full answer. That's just the factored form of this. We took a 3x from the very beginning out, so you must still include that in your final answer. So the factored completely answer would be 3x times 2x minus 1 times x plus 5. Once we're done with just factoring, now we solve equations by factoring. To solve equations by factoring, your equations have to equal 0. Number 16's equation already equals 0. So what we do is we factor x squared minus 16, which is x minus 4 times x plus 4. When it's equal to 0, you can set both of these factored parts equal to 0 separately. So we have x minus 4 equals 0 and x plus 4 equals 0. You solve these, add 4, you get one answer is 4, minus 4 minus 4, you get another answer is -4. So your two answers would be 4 and -4. Number 17, you can't solve it yet because it doesn't equal 0. You have to be able to factor it to solve, and it can't be factored unless the equation equals 0. So step 1, you subtract 12 from both sides to get 2x squared plus 5x minus 12 equals 0. Then you go ahead and you start factoring this problem. So this is another one. The trinomial does not begin with a 1. So you multiply the a and the c number. 2 times -12 is -24. And then you find the factors of -24 that add to be 5. So thinking of the factors of -24, we have 8 and 3. Positive 8 and -3 add to be 5. So we split that middle term up into 8x minus 3x minus 12 equals 0. And factor by grouping. Greatest common factor on this side is a 2x. Greatest common factor on this side is a -3. We regroup. We're going to regroup this as 2x minus 3 times x plus 4 equals 0. We set both of these things equal to 0. And we solve. This one takes 2 steps. We add 3 to both sides, then we divide by 2. So in any order or any format, either 3/2 or 1.5, just look for the answer that would represent 3/2. And then this other answer is -4. All right, the last one on this page, number 18, is asking us to find the domain of functions. When we're looking at functions, and you're finding the domain, you're trying to look at what values work for x. If you're really unsure when you get to the final, take your graphing calculator, put this in and see what it looks like. So you can see if there are times the graph doesn't work. We spend a lot of time looking at fractions. We know that when you have a function, the denominator of a fraction can never equal 0. So I basically only focus on the denominator and I solve the equation for when it does equal 0, because when it does equal 0, I know that the domain does not work for that number. This one's nice and easy. You don't have to factor it. We know that when x equals -7, this domain will not work. Basically, the domain is anything but -7. So the domain can be listed like that. It can be in interval notation, but any domain for this function would be any number but -7. All right, on to simplifying expressions. Number 19's fraction has a single term as the denominator. When you have a single term as the denominator, I feel like the easiest thing to do is take the numerator parts and divide them each separately by the denominator. So I can rewrite it as x to the third over 2x plus 8x squared over 2x. Simplify what you can. You have x to the third power at the top here over a single x on the bottom. One of these x's will cancel out with just one of these, bringing this down to be x squared over 2. And then this one, we can do 8 divided by 2, which will turn into 4. So hold on, this is going to be x squared over 2 plus 8 over 2 is 4, and x squared over x. This one of these will cancel out with this one completely, so you will just be left with 4x. So your answer is x squared over 2 plus 4x. For number 20, because I do not have a single term and there's a minus sign here, I know that I'm going to have to do something else. I will not be able to use that like trick I did in number 19. When you see a polynomial in the numerator that doesn't look like it's factored, that's your first step. This trinomial, thankfully, is an easy factoring problem because the leading coefficient is 1. So we just think about the factors of 18 that add to be -9. All right, so in order for something to multiply to be a positive and then add to be a negative, both of them have to be negative. So -6 and -3 will be the two lucky numbers. So we can just go ahead and factor it right from there as x minus 6 times x minus 3 over x minus 3. When you have fractions, if you have the same thing on the top as you do on the bottom, you cancel them out. X minus 3's cancel. This reduces down and simplifies to just be x minus 6. All right, multiplying fractions. When you're multiplying fractions, we know you multiply the numerators times the numerators, the denominators times the denominators. I'm basically just going to do that and simplify last. So 2y times 5x to the 6, y to the second. 2 times 5 is 10. Y times y to the second is y to the third. So this numerator is going to be 10x to the 6, y to the third. Over 3 times 10 is, 3 times 10 is 30. And x times y is going to be xy squared. We then use exponent rules to simplify and then regular fraction rules to simplify the coefficient numbers. 10 over 30 is really 1 over 3. You can put the 1 or you don't need it. For now, just put it. X to the 6 over x to the first is going to be x to the 5th power up top. Y to the third over y to the second is y to the first power up top. So your answer will end up just being x to the 5th times y over 3 for number 21. But of course, as soon as we see polynomials that are not single termed, like in number 22, you should be thinking, all right, in order to multiply these numerators times these numerators, I'm not going to actually want to multiply 3r plus 1 times r squared minus 7r plus 10. You'll end up with 6 separate answers that can be simplified. And then how would you factor that? It gets too crazy. So what you do is you factor it right off at the beginning. 3r plus 1 cannot be factored, so it stays 3r plus 1. R minus 2 cannot be factored, so you leave it as r minus 2. But r squared minus 7r plus 10 can be factored into r minus 2 times r minus 5. Over r minus 5 cannot be factored. It's already ready to go. When you're multiplying fractions, essentially you're multiplying everything in the numerator by the other things in the numerator and everything in the denominators. So it's essentially turning into one big fraction with all of the stuff staying exactly where they are. Because it ends up being one fraction, you can cancel out whatever you see that's the same in the numerator and the denominator, like the r minus 2's and the r minus 5's, leaving you with the final answer of 3r plus 1. When you are dividing fractions, you will eventually multiply, but you are going to have to do a couple of things first. So I like to take the original problem, factor everything that I can first, because I can see a couple things just looking at it right away that these are probably going to be factored. I know 4x, can't really do anything with that. 3x minus 3, take a factor of 3 out, and you're left with 3 times x minus 1. I'm going to keep the division symbol for now. I'm going to take a factor of x out of the top. And I'm going to factor the denominator. That's going to end up being x plus 2 times x minus 1. When you divide, you keep the first one the same. You have to keep the first one the same. You change division to be multiplication, and you flip the second one upside down. So the x plus 2 and times the x minus 1 goes to the top, and the x times x plus 2 goes to the bottom. Then you're multiplying. So the same idea applies in that these things will all end up being multiplied. So you're going to have one big long fraction here. Well, when you have things that are being multiplied, if you have the same thing on the top as you do on the bottom, you cancel them out. X minus 1 and x minus 1's cancel. X plus 2 cancels. This x right here will cancel out with this x right here. So those are gone. The only thing that you're left in this entire problem is just 4/3.